Welcome everyone to this Tech Talk. It's organized by our company Riwers. And today Christian will tell us about a very interesting topic about scraping using AI tools. So we utilize this on one of our projects, and I think that the results are very interesting to share. So how we did it and what were the challenges. So thank you very much, Christian. Floor is yours.
I would like to welcome everyone in this presentation about scraping. And as I was preparing for this presentation, I was thinking about what's the best way to convey and to distribute all, not just the technical aspect, but also some best practices and challenges we had to face during this project. So I decided to walk you chronologically throughout the entire development of the project, not just jumping into conclusions. So I'll highlight some interesting obstacles and challenges we had to face. First, quick introduction to the project. From the customer, we received a list of URLs, a list of websites that pointed to a list of products. These products were mostly related to construction materials and similar materials. From these websites, we had to investigate which of websites are product links, which of them are products, and obviously we had to scrape some data from the website. The challenging point for this project was that this data was stored not in websites itself, but mostly in PDF files. Throughout this process, we had to also face the challenges like pagination of the product, some dynamic websites, fetching, and obviously data quality was really important in this project. So for this development, we defined 4 key steps. First was basically visit the website, somehow scrape it, somehow transform it to machine language, and somehow fetch the information from the web page. These pieces of information were most likely PDF files, and reading PDF files also is not an interesting topic for us because nowadays you can download any library that will download the data from the PDF and transfer it to the text. Also, the output, the JSON, is not a very interesting topic because, well, you can transform basically any data to any format you want. But the interesting topic was this magic that needed to be somehow revealed, and somehow we had to transform non-standard data into some standard format of this. And just a quick introduction to our stack. For the application runtime, we used Nest.js, which is a really popular, robust JavaScript library. With the commander, it allows us to use it as a command line interface application, and even though it's mostly backend application. You might ask, why not Python? Because Python is widely used for AI in this world. But since we all knew better TypeScript and JavaScript, basically, we decided to go this way. And also, all providers of AI or let's say large language models support also JavaScript, not only Python. So this was the decision. Next is Postgres, which is also a database really popular, and it supports JSON. Again, you may ask, why not use MongoDB since we used JSON files? Well, as it turned out, we didn't have any specific schema to begin with. Our customers didn't provide us with specifics. We had to define a schema ourselves, and the schema was changing a lot of the times during the development, and let's say migration from one state of database to another state of database was easier in SQL rather than MongoDB. For LLM, we used OpenAI, which is well established and one of the first pioneers offering LLMs commercially. And this was as our obvious and first choice, and we actually didn't consider any other LLM because it was sufficient for our needs. And last but not least, AWS, which is provider of say programming tech infrastructure. We use the Textract for OCR and S3 buckets for storage, but this is not important aspect, not that important. So let's begin with the actual implementation. First we have, I'll turn on my pointer. So first we had to connect somehow to ChatGPT. Then obviously for every product page we had to somehow get all links to PDFs, for which we use Cheerio library, which is jQuery-like library for parsing and working with HTML files. This turned out to be a perfect solution for the needs for our needs. Then we had the mentioned schema. This was just a JSON schema I didn't want to include here. It's not really that important. Then we uploaded files to ChatGPT and basically created a thread. These two steps were important because we used OpenAI or ChatGPT beta version 2, which allows us to work with files more seamlessly than version 1. And it is also able to function within a thread, which you can imagine as being on a ChatGPT website and asking some questions to GPT. You also are in a thread. And then we asked it to use schema that we wanted and some files that we provided. And it was commanded to get or to return all attributes that were relevant for us. We had a list of more than 100 attributes, so you can imagine that this was not an easy challenge if it was done manually. So GPT was a good choice for this, or basically any LLM. And then we just saved the output to the database. This approach turned out to be not that wise, didn't get us where we wanted to be, because it worked with entire projects, with all the files that we had available, and but it was fast and served us as some kind of cornerstone upon which we built our entire application and project and architecture. One of the first challenges that we faced were time challenges, because implementation took longer than we initially anticipated. For this, we were suggested to use ChatGPT also for scraping website itself, because up until this point we were using Cheerio and manual scraping. We had to somehow build the path to PDF files, fetch them and somehow sort them. And ChatGPT turned out to be a good replacement for that, and it offered us more time to focus on really important things rather than building some CSS paths to files. This also brought the challenges because, as I mentioned, we received a list of links which had which pointed either to product page, product group page, or product it's a list. And ChatGPT needed to be able to distinguish between these three types, and it was not always easy to tell it basically which page type we required it to be, because, for example, product detail page needed to have PDF files and stuff like this. and ChatGPT not always realized that because some pages which were product lists appeared similar to product details page. And also some challenges as fetching data through Ajax, some dynamic pages. These were challenges that it had to overcome. But still, after good debugging of this code, we finished, or we ended up with really good, let's say, helper functionality. Another issue we faced was cost. Unfortunately, ChatGPT 4.0 model is really expensive, but we used that initially because it was able to work with, let's say, any kind of media, but mostly PDFs. By the time we definitely needed it, also offered some basic OCR, so we didn't have to use ours. But the pricing was very high. Just for comparison, ChatGPT 4.0 cost 15 American dollars for 1 million output tokens, versus ChatGPT 4.0 mini, which cost 60 cents. It's a really huge gap between these two. And ChatGPT 4.0 mini is still better than its predecessor, 3.5 turbo, and this turned out to be better replacement. Yes, 4.0 mini is mostly designed for text-based tasks, so we had to somehow build our architecture around this fact. So obviously, with the new model, there were new challenges, as the ones I mentioned. These were that we had to convert the PDF files to the text manually, and there were a lot of cases that we had to overcome. First of which were corrupted files, or not entirely corrupted, because they were visible when you open it in a browser. But there was some encryption included in transferring PDF files into text. And also tables. We had to work with a lot of tables. And as you know, you cannot store properly tables in text format. It has to be somehow pre-processed. For this reason, we use Textract, which is OCR from AWS. It's AI-powered and offers possibility to focus on simple lines, forms, and tables, which were crucial for our case. And using Textract with 4.0 mini turned out to be way cheaper than using standalone 4.0 model. So I want to demonstrate some cases that we worked with. This is a standard table that we had to somehow parse. I want to point out that all tables tables could differ between different providers, which is obvious because not every provider needs to follow some standard about how they build their tables. But even within one provider, it was really different. By different, I mean that some columns could be switched, so instead of diameter and length, it could be length and diameter, or it could be some columns were missing even for some products, or the table could be transposed as well. By that I mean that all metrics would be in rows instead of columns, and columns could contain variants. So obviously this is really hard to work with when doing manually, and you need some help from AI. When parsing to text, best case scenario you might get is this. And everybody who has studied information technology knows that this is really example of data parsing, and they met this example a lot of times in their study, I assume at least. And this is really easy to parse even with manual scraping. You don't have to use these with LLMs, but to my surprise, they turn out to understand the context of columns and rows really, really well. It was not a pain to work with. But there were cases like this where you cannot really tell what's going on there. You cannot tell where's the white space, because the only white space is here between variants, but between the numbers you don't really have anything that would tell you this is 300 and this 3 belongs to these 3. It's pain to work with, so for this reason we had to use this text struct. And worst case scenario, as I mentioned, some files were corrupted, and when transferring them to text, they just return this one. Okay, so now the fun part of optimization and fight with LLM begins. So first, realization that we made was that we need to use smaller queries and somehow batch them, because LLMs are not supposed to work with large prompts, and it could lead to to more hallucination. And when they need to output a lot of data, it's not good for them. You can imagine that as being in a conversation with someone who asks you about your favorite topic, let's say, I don't know, F1, and you need to explain everything that you know with very specific formula. You cannot do this because you forget everything, and basically it's not good. Even when presenting this, I need to use some notes because I would forget all the aspects that I need to mention. So when splitting the prompt, this turned out to be really a good step forward because it offered ChatGPT more focus. Also, you can imagine that as if someone asks you a really specific question about the topic you like, you're more focused, you can provide more, let's say, more quality of information. But we had to somehow, we had to somehow ensure that LLMs would return only the data that are contained in the files, in the source files, because obviously it tends to hallucinate, and we somehow needed to, we needed some validation mechanism in order to check what's real and what's hallucinated. So for that, we implemented a backcheck. Backcheck is a mechanism to check whether offered words from ChatGPT or from LLMs, basically, if they are contained in the source files. This, as I mentioned in the previous screens, when converting PDFs to text led to some hash of strings. This was impossible. Therefore, OCR was good, and we actually checked against the OCR itself, not against the data that we had. But the important thing is that these checks were good step forward, because even though they ChatGPT fails, for example, once, we repeated the process of prompting up to 3 times, and most likely it turned out to be actually false, and the second round of prompting actually returned the correct strings or correct data. But after 3 times, when it led to error, we had to do some manual revision, and obviously there is nothing you can do about that, because there might be some cases where backchecking is not enough. These cases could be something like this, which is units, because if you have kilogram per meter cubic, it's the same as kilogram per meter cubic, obviously, it's the same. The only difference is that 3 in first example is written in standard casing, whereas in the second example is subscript. And these two units are contextually the same. The only difference is that if you compare it as two strings, it will lead to false positive, let's say. Also, the second case was word splitting. We dealt with a lot of chemicals, and the chemicals were contained in small tables, which obviously, at some point, you need to put a hyphen there and put the rest of the word on the second line. So we had to do some additional logic around backchecking, but this validation mechanism is really important when you are working with LLM, and quality data is important to you. So when we dealt with data quality, we were able to run scrapers one by one, but we were hitting concurrency limits of ChatGPT, and basically rate limiter didn't allow us to to continue with this rate, so we somehow had to implement a locking mechanism for processes. If you study in a tech high school, also you maybe remember something like mutex, which basically means that when the process is going, you need to fight for resources as two processes. One will acquire the lock, and the other has to wait until the first one finishes, and the second one can take the lock and continue with prompting, or continue accessing the resources, which in this case were access to ChatGPT and its API. Next one is, after some time, we realized that some pieces of information are contained only in specific PDF files. For example, let's say we had to scrape some biocides, which were chemicals. They were most likely stored in files called safety datasheet. So we had to, we could put to prompt only these files, which decreased amount of data coming into ChatGPT, therefore decreasing the time that it needs to process the data, and decrease cost, obviously, because the less data you provided, the better. We refined this process throughout the whole duration of project, and there were cases like not only biocide, but some additional information related to identification, some usage of the product, and so on and so on, were contained in specific files, so we didn't have to provide it a whole bunch of files, only the ones that were relevant. One of the more advanced things that we needed to ensure when it comes to data quality was something called reasoning. Reasoning is, there are more kinds of reasoning, but basically in our case it was asking itself if the result that was provided by ChatGPT is correct. And this improved just a little bit, but it improved the quality of data after all. We use that for mentioned biocides because a lot of the time ChatGPT basically doesn't know what is biocide and what isn't. It returned only some list of chemicals, of which some of them were biocides, some of were not. And after asking this question, which is called self-reasoning, this improved improved the data in a way that it was able to filter out non-biocides and left us only with biocides which we needed. So what is actually reasoning? As I mentioned, it is ability to process information, draw conclusions, and solve problems in a logical manner. In this case, we just had to ensure that the data that we received was actually correct, and therefore we had to just ask the same instance of ChatGPT whether this is correct. This was very simple approach towards reasoning, but I will explain a proper implementation or suggested implementation later in this presentation. Not only we had to ask different questions per different parts of products, which was prompt splitting. We also had to differ between different providers because different providers use different files, obviously, and we had to adjust all our prompts to every provider, or most of them require a manual changing of the prompt. And since we used one global prompt for every provider, we had to somehow overcome this issue and implement a mechanism that tailored prompt specifically for every provider. We prepared it in the way that we had some baseline prompts, which were after or when the script was run, the prompts were copied into the directory where the scraper was running, and we could adjust it in any way that we considered to be better, obviously. So we could use more individual prompt, and basically we can tailor anything to specific provider and therefore increase data quality. Well, last but not least, I almost forget to put this information into presentation, but this immensely helped us in running prompts in let's say hitting ChatGPT limit and hitting limit of our time, and it is caching. Caching, by caching I mean that when you need to request for anything from OpenAI or from Textract, it's really expensive, not only when it comes to money, but also when it comes to time. And therefore, why would we need that for the same prompt? We don't need that. When you have the same prompt, same data, we could just reuse all the information that we already scraped or already fetched from OpenAI or from Textract. So we implemented it that way. Obviously, we had some man in the middle, which was our machines. We stored the cache on our file system, where this was also a possibility, but file system was really enough. It was easy to debug. If I wanted to see what's coming from ChatGPT, I could just open file and look for that information. And as I mentioned, we could just use prompt and data, generate some hash, because otherwise you need to somehow identify uniquely which prompt and which files were used for specific request, for which the hashing functions are perfect for. And then if the hash was contained in the cache, so then we return the cached value. Otherwise, we would go to OpenAI or where we wanted it to go. This really helped us. So the entire process was revolved around building the cache, and from the cache we were able to build the actual output for the customer. So that was mostly what we implemented. As the project was heading towards its end, I was considering switching to some EA framework. I considered, for example, Haystack, LangChain, which is very popular, or Llama Index, which is basically something over Llama model made from Meta company. But this switch would require huge refactoring and huge mental energy from our side, and we didn't have that much time to switch into these frameworks. So just to summarize the whole presentation, there are some key points that need to be considered when it comes to AI scraping. First is cost optimization. You need to see whether you really need the model that you're actually using. You need to consider whether switching to cheaper model is not would be enough for you. Use AI where possible. If you have the option to use AI for some manual activity, just do it because it really helps you. To extract, by that mean I use any technique that helps you to get you where you want to be. I mean, when it comes to, for example, this case, if you need to somehow bypass the fact that the text representation of PDF files is incorrect and broken, then you need to somehow use some third-party library. Smaller prompts, as I mentioned, it keeps focus. Validation mechanism, when you really want to ensure that your data is of high quality, you need to somehow implement also this. Know your data. This is really generic recommendation because it applies to all tech industry in any project, not only using AI. It requires you to know the data or business knowledge, basically. Implement reasoning or any kind of logical solution to problems that you can do with LLMs. Individual prompts, by that mean they need to be really tailored to your use case, otherwise you will be getting let's say not that correct results. Caching, any kind of improvements when it comes to optimizing runtime is great, and sorry, and leverage usage of AI frameworks. Now I could end this because up to this point, everything that is stated here we used in, except the last one, we used in our project. But I also wanted to share how I would do that in the future and provide some recommendations for future scrapers, let's say. And it's by AI agent collaboration. It's just one way of how you can do this in the future. And it will bring you more future-proof solution and more secure solution. So let's start with the thing that what is agent? Agent is AI-powered entity that is able to make decision and somehow, let's say, make informed decision. You can imagine it as being expert in some field. As you are in tech, for example, agent can be code writer, let's say. Agent can contain a set of tools, and these tools basically are anything that you will provide them when it comes to some external connection to external world. It can be either access to your files on your computer, it can be access to some API, access to some database, anything that you will provide, it can use. It also uses or contains history, basically not to forget what you asked him and to infer some information from the context that you were using. And also the main task, which is basically the prompt, how he should behave, what is he, let's say. You need to inform him that you are, let's say, tech agent coding software, or you are weather agent, and when I ask you what's the weather in some point, in some geographic location, you will provide it. And also agent obviously can collaborate with other agents, and they can send each other messages, ask each other questions. They basically know about each other, know what are their functions, and know where to put another further step, let's say. So for our case, let's say we want to build scraper for biocides or some chemical substances, which also comes with verification of this data. So for as a first point of contact for any application runtime, you would get a supervisor. Supervisor is just an agent that you can imagine it as being manager in a company. It transfers your request into one of your subordinates, which you know that they will make your job best. So, for example, in this case, it could be some chemical quality extractor. Intentionally, I didn't mention biocide extractor because for this we could use, or this network we could use also for other chemicals, which we had to do in this project, for example, formaldehyde, and halogens and stuff like this. So it could do also this extraction of this data. So obviously it needs access to the files, which, with that being said, I will provide him tools with that are able to extract the data from the files by any means necessary. I'm not getting into that right now, but important thing is that it needs to access to the files. And also it needs to have some task, because otherwise it doesn't know what to do. So the task for this node or this agent is to fetch all relevant substances. So in one case it could be fetch all biocides. And the last node would be a chemical substance verifier, which is agent that has access to a database of all chemicals. It doesn't necessarily need to be SQL database. It can be some access to API where our chemicals are somehow listed and categorized, and contains prompt to filter invalid substances. So for example, if you provide them with formaldehydes and you really need only biocide, it is able to check the database, compare the data that is there, and filter out invalid substances. So obviously there are many ways how can you implement this in future-proof, with future-proofing in mind, but this way could be really secure, because you only give access to agents where they need to have access. It's really easy to see where the flow goes, because you can debug it step by step or agent by agent. And yeah, it's a clear workflow. So, but as I said, it's one suggestion. There could be another better approach for this, and but that's it. I guess that concludes our presentation. So thank you all for paying attention and bearing with me.
I would say that let's get to the questions. And so let's get started with the first one. So Jerguš is asking how much you had to adjust from site to site. I guess it's impossible to make something universal.
Well, yeah, true. But as I mentioned in the presentation, we implemented sort of prompt tailoring, which meant that we could adjust any prompt to any specific site. It was not always 100% correct, but it helps us a lot, because you know, the data is different per each provider, and even each provider has different data, so we had to differ not only provider per provider, but also product per product in some cases. But for this we use just different prompts for different providers.
Was it like vastly different, or was there also something that you could like reuse?
I mean, the core was there, but we had to tweak some locations of some information, because some products included all information in separate files. Some products had only one file which contained this information. So we had to just adjust where this information can be found, and basically how to get there, how it's labeled, because this was really important. In every provider uses different wording for different sections and different labels for data.
Okay, cool. So then let's go to the second one. What was the most difficult part about it? Was there something that you were not expecting, or that was more difficult than what it looked like at start?
I would say the most difficult part was the thing that we didn't have specific schema. We had to migrate from one, let's say, format to another a lot. It was hard to keep all the data, because it was stored in different formats. Then we had to unify it, then we had to transform it into another format, then another format, and keeping the same data while changing the format isn't always the easiest task to do. But I kind of anticipated this because we didn't have the schema since the very beginning of the project. The thing that I didn't anticipate was runtime because from the very beginning we told ourselves how long can this scraper run in average. Let's say it can run for half an hour. We had scrapers that were running 24 hours, 48 hours.
Okay.
So this was really surprising to me in this project.
And what took the longest time, like to wait for the responses or?
Wait for responses, and also as I mentioned, we had some locking mechanisms for every process. So if we had 4 processes or 4 scrapers running in parallel, they all had to wait until it's their turn to ask GPT some questions. So they had to wait for each other. Then we increased the number of parallel connections, but still, we had to wait for a response from GPT, and that took the longest time, I guess.
Okay. So, but the more obviously, the more parallel connections, the faster you are burning money.
yes, exactly.
So, do you have also like overview how much like all these processing through the Open AI API costed, because it's like a big project, a bunch of data.
I'm not even sure if I have access to this information, so
okay.
you should be aware of this one.
I know that it was in a few thousands, I think. Yeah.
For the entire project.
Yes,
right?
for the entire project. Obviously, like it might seem like a lot, but on the other hand, like the development time where we would be writing these scrapers manually can be even more, right?
Yes, exactly.
So, and this nicely ties to my next question, which is here. How much time did you save or lose using LLMs for scraping? Would it be even faster next time around?
It would be faster. It could be faster with the approach I mentioned on the very end. But I would say we saved years. I can imagine implementing every scraper for whole 2 weeks, let's say, one sprint. Per one sprint, you can implement one scraper. And in this case, I guess Vladimir was really productive in this manner. He could implement 5 scrapers per day. The runtime was the bottleneck, I would say, but still, implementation time was, I mean, seconds, minutes. You can count it.
Okay, that's amazing. Very nice. So, is it possible to use DeepSeek open source model as a separate service that can be hosted by yourself?
Yes, we were thinking about it. Not specifically DeepSeek, but Llama or some open source model. Although it requires huge computational power in addition to what we were already putting into. I mean, building a cache around some data, fetching data into like runtime memory, storing it, it's not really cheap operation. And in addition, we would need to host it somewhere. And I mean, if I host it locally, I would burn my computer, to be honest, I think. But if we would host it somewhere like internally within Riwers, I would say this is possible, but you need to know what you're doing, obviously.
Yeah. Then we can just take those graphics cards and play some games or something.
Yeah.
So, do you have some statistics or how many files you processed, and what is the quality of the output? And here, maybe I would even add like how big was the error rate, because probably you didn't have like 100% always perfect data, right?
Yes, I guess it's impossible to even reach 100% unless you really want to devote your time into scraping data from one provider and ensuring it's 100% accuracy. We had feedbacks from customer about some issues which I considered not being that major, with some differences from beginning. It was obviously larger error rate, but as we were reaching towards the closing of the project, it was very slow, and we even been told that we are slightly worse than the company that's whose main purpose is just scraping. They have like 10 years of experience, and we were slightly below that. So I guess we were pretty good in, given that it was our one of our first projects when it comes to scraping. So yeah, I guess I have a good feeling about it. I don't have numbers when it comes to files, but thousands, definitely thousands.
So like a lot of PDFs, multi-pages, and
Yeah, definitely.
then you have like, okay. Good. And how close were you to the competition, like percentage-wise? Like it was like very close, or we're talking like 10% or 1% or even less?
I don't have this information.
Okay,
I'm not even sure that they can
so
share
didn't want
this
to disclose
information.
it. Okay.
Yeah.
Okay. But in the end, like the quality of the result, they were satisfied.
Yes, I had a good feeling about it because we were able to, as I said, the single bottleneck was runtime. Otherwise, we were really good when it comes to quality of the data. We had some feedbacks, obviously, from the customer. Some things were repeating, but this was about just some minor stuff. I didn't consider it to be something major.
So Andre is asking, what was the general amount of data processed? You already said that you don't have specific number, but the second part is, how did you test your results?
Well, testing was done by Dmitry manually, and obviously by Peter also. Those were our two testers, which we didn't have a way, basically, how to test it. We had some validation mechanism, as I mentioned, at the backcheck. This was the only automated validation that we actually had. Otherwise, it needed to be manual. But also, customer was testing it this way, that they took random 5-10 products. They went through PDF files and compared it to our results. And I guess it was really satisfying also for them, because when they found something, it was most likely in one file for every provider, which is, I guess, good rate for the errors. And
PDFs are a horrible format to work with, so
I agree.
Like when you have the table or something like that, then it's not as easy as in HTML. And yeah. I actually, when you told me that you have these challenges with the tables, I realized that it's even more accurate if you take the table, you take the PDF, convert it to HTML, and then put it to the ChatGPT, because then at least the structure is right.
Yes. I mean, if the structure was right from in-text representation of PDF, ChatGPT, as I said, surprisingly, it was really good in inferring which column belongs to which metrics, and I had nothing to do, basically. It did everything for me. But yeah, when this was somehow swapped around and messed around in PDFs, then we had no choice other than either convert it to HTML or use OCR. But OCR turned out to be the more universal solution for this, rather than switching it into HTML, because it wasn't that stable as well. It could get messy even in that format.
Cool. So, have you researched any specialized online services for the job?
Not specifically when it comes to scraping, because most scrapers that I found were into scraping data from HTML, not from PDFs. When you want to use some online tool for scraping data and for scraping or reading PDFs, you might as well program it yourself, which obviously we did. So we could use some no-code builder, which would transfer our PDFs and put it into API of Scraper, but we wouldn't be that in control of the flow, and I assume that quality of the data would be terrible compared to what we had.
How do we know when we have a cache hit based on the user's query text? Do we compare the hit rate or the user's request?
We compare basically the hash that comes from prompt and the files that were put in the query. You put all together, compute the hash from this. Obviously, you need to know that the hash function will return the same hash for the same input, and inputs differ even when there is slight change. If I would remove that from prompt, it would calculate completely different hash. So that's how we knew that we hit the cache.
It's like expertise in a health system, general doctor, specialized doctor, and more specialized doctors.
I guess it relates to agents.
To agents, okay. So Eric is asking, I skipped a big part of the session, but how close are we to AI vision scrapers? I believe it's possible to teach an AI to read a content part of each website.
I mean,
so
there is no problem in reading website, I guess.
Yeah.
There were problem reading PDFs which were not that well structured and somehow encrypted. So I guess in web pages, they're really good in reading web pages right now. So in the future, I guess that should only get better.
Okay. So the websites are not your enemy, but PDFs are.
PDFs are everyone's enemy, I guess.
So the last question is, how did you recognize the information represented by icons? Is it not a problem for AI? You mean like if you had checks, so like, does this product contain some chemical? Check, and then scrape it, right?
Yeah, we had actually most of cases when it comes to eco labels, which are, for example, those CE things that are rarely referenced as text, but they are contained in when you open the website. For this, we had to use HTML website, not just PDFs, because image recognition was not part of this project. But sometimes they could be found on websites, and in the alt attribute of image tag, you could find the name of ecolabel. So that was the only thing that we had to mess with, let's say. But otherwise, there were no information hidden in images apart from these ecolabels.
Cool. So now we have essentially like a Kickstarter set up for our land registry. When they start to scan all the certificates of ownership and they need to digitalize it, then we can somehow then help them out, right? So like, or if they have PDFs or something.
Definitely, I can reuse everything that I have.
Well, hopefully they will be able to restore the backups. Anyway, thank you, Christian, for introducing us into this interesting topic, and especially sharing your experience with everyone here and also online, because let's face it, a lot of this stuff is new, it's changing every day, but the real hands-on experience is, I think, what is the most valuable. So again, thank you very much.
Thank you also for this opportunity to speak here and to convey my experience that I had with this project and with LMM specifically.